Hello everyone, hope you guys are doing well. In today's class, we are going to cover isometric projection of an inverted cone and a simple cone. So let's move to the problem. Draw the isometric projection of a cone of diameter 50 mm and axis of 80 mm when, first part, it is resting on its base on HP and keeping axis perpendicular to HP. Second, it is resting on its apex on HP and keeping axis perpendicular to HP, inverted. Now, as you can see, it's a cone of diameter 50 mm and axis from the center of the base circle to the apex, imaginary line perpendicular to base. Length of this line axis is 80 mm. In the first part, it is resting on its base on HP, so it is resting on its base on HP or base is contained by HP, keeping axis perpendicular to HP. Okay. Now for the construction work, first we have to start from its base, circular base. So first we will project its circular base on the horizontal plane, and then we will mark the center of the base circle. Then from center to apex, so from center to apex we have to draw the axis. Last from apex towards generators, we have to draw generator lines. So this will be the process. Now for construction, we know that helping figure for the circle of diameter 50 mm will be a square of same diameter. So first we have to project a square here of size 50. So taking ISO 50, using isometric scale, taking ISO 50 along first ISO axis and second ISO axis. Then from these 2 points, we have to draw lines parallel to first and second ISO axis. Parallel to first ISO axis and parallel to second ISO axis. Parallel to second ISO axis. Okay. Next, we have to project a circle here, isometric projection of circle. So using method of 4 center or 4 center method for the construction, because 4 center method is the best method for the construction work. So as per method, first we have to divide all 4 sides of the helping square into equal parts. So simply by bisecting, we will get these 4 points. Next, we have to draw the diagonal, which is by length, which is larger. Then next step, from midpoint to opposite corner. So if you draw lines from the midpoints to opposite midpoint, midpoints to opposite corner, and from corner to opposite midpoint, again repeating the process for the points, midpoint to opposite corner and midpoint to opposite corner. Now we have all 4 centers of rotation. First center, common intersection point. Second center, the corner. Third center, again common intersection point. Fourth center, the corner. Now next, we have to draw the final ellipse, which is the view, which is the isometric view or isometric projection of this base. So starting from first center, this is my first center, and from first center this will be the radius, first radius. So this point as center, this much as radius, first part. Then this as center, this much as radius, second point, second part. Third center, third arc length or third radius, fourth center and fourth radius. So this is the base or base circle. Next we have to mark the center of the base, which is also the center of this helping square. Again, from midpoints we have to draw lines parallel to first and second isoaxis. And then parallel to second isoaxis also. So, stake. So this is the center. This point is the center of square, center of the base or center of the circular base on which this cone is resting. Next we have to draw the axis, solid axis of the cone starting from the center of the base. So drawing line parallel to third or vertical isoaxis, and length is 80 mm. So again we have to take isometric length corresponding to 80, ISO 80. Now this is the apex point. Now we have to join the generators, we have to draw the generators. So from the apex point to the base circle, we have to draw two generators, one on left side, other on right side. But please make sure that the generator is meeting circular base, part of the circular base on this point, or is tangential. So these generators are tangents on the base circle for the projection. So from this point to this point, this is frontal portion or front portion of the circular base, which is visible. Also this part is also generator, this part is the part or portion of generator, but the point at which this generator meets must be tangential. Next we have to show the axis, dimensions of axis and base. So drawing line, extending lines parallel to first isoaxis from the center and from the apex, and then drawing line parallel to solid isoaxis or vertical line. Axis is 80, and we have to show the diameter. Extension line parallel to second isoaxis and dimensioning line parallel to the first side or parallel to the first isoaxis. Diameter is 50. And last direction of observation, line parallel to second isoaxis for this direction and preferably from the center line. So this is the final projection of the cone, which is resting on its base like this on HP. In the next part, it is resting on its apex on HP and keeping axis perpendicular to HP, or simply the cone is in inverted position. So now we are drawing projection of an inverted cone. So the cone is resting on its apex point on HP and the circular base is on the upper side. So now here first we have to mark the point, apex point on the horizontal base, and then this point, circular part. So for inverted cone, again on the base we have to mark limits of 50, ISO 50. Then we have to draw lines parallel to first and second ISO axis. Second parallel to second side. Right. Now here, for the upper base, simply we have to draw lines parallel to vertical axis, and then we will project the upper helping base or upper square, and on that base we have to draw the projection of the circular base. So from all 4 points, drawing lines parallel to third ISO axis. Parallel to third ISO axis. From fourth point also parallel to third ISO axis. Then we have to mark limits of the upper base. So length is, say, this is the length, 80. Again we have to take ISO 80. Okay. Now I am cleaning this part. Next, we have to join all these points from each other. So this is the top base, and on the top base or on the square geometry, we have to project the circle, isometric projection of circle. Again repeating the process. What we have to do? First we have to mark all 4 midpoints of the square. Next, diagonal. Next, from midpoint to corner. From midpoint to corner. From midpoint to corner. Same for fourth side. Now these are 4 centers of rotation. First center, second center, third center, and fourth center. Now here, the upper circular base is visible, is completely visible here. So we have to show complete circle or complete ellipse. So this is first center and this much is first radius. First part. This is second center, this much is second radius. Second part. Third center, third radius. And fourth center, fourth radius. Right. Now apex point. Here the cone is resting on its apex, or the point apex point will be on the center, of the helping square or helping box. So we have to locate the midpoint of the base square here. Again we have to divide all 4 sides and then drawing lines from these points. Common intersection point will be the center of the base, and this is the apex point. Also we have to show the center line and solid axis. So from sides, drawing lines parallel to first and second isoaxis. And then solid axis from base center to the apex point. Last, generator. Again, generators are tangents to the base circle. So drawing tangential line towards the base circle. Last, dimensioning. For dimensioning, drawing lines parallel to first and second isoaxis for 50, extension line parallel to second isoaxis, dimensioning line parallel to the side of first isoaxis, and solid axis extending apex point and the center line, and then dimensioning line parallel to solid axis, and last, direction of observation, preferably from the center along second isoaxis. So these are final answers. First, when the cone is resting on its base like this, and second, inverted position when the cone is resting on its apex. Now please solve these two problems in your sheet. And if you face any problem, or if you want some more explanation, also if you want some more problems to be covered, please write on the comment section.